This is a transmission line question from the 2011 VCAA examination. The question says we've got a hydroelectric plant generator, it's supplying 50,000 volts RMS and the current is 15 amps. That gets transmitted 20 kilometers and gets stepped down in a transformer and supplies a town with 250 volts RMS. The first question asks us to calculate the power supplied to the transmission lines, and you have to show your working. So here we're going to be using our most basic power formula, P equals VI. We have a voltage of 50,000 volts here, so the power is going to be 50,000 times the current, which is 15 amps. If we put that into a calculator, we should get 750,000 watts, which we can write as 750 kilowatts. You would have to check the exam and be careful that you answer in exactly the units that they specify. So depending on whether they ask for watts or kilowatts, you should answer accordingly. For the next question, the townspeople are concerned about high voltages because they're a bit silly, and they ask if they can transmit at a lower voltage. This is going to increase the power loss, and you're asked to explain why. The question is worth 3 marks, so you should expect to have about 3 dot points or so. So first off, we need to look at what's going to happen if we transmit at a lower voltage. We know that P equals VI. So for a constant power, so the power is the same, the voltage, if it goes down, the current is going to go up. The power loss is equal to I squared R. So therefore, if the current increases, then power loss will increase as well. And this is obviously a bad thing because you don't want to lose power for no reason at all. Proposal is not accepted, as it shouldn't be, and they're transmitting as they were originally designed. So the total power loss in the lines is given as 9,000 watts over here, and we're still transmitting at 15 amps. So we need to calculate the resistance of our transmission line. So we know that P equals 9,000, I equals 15 amps. Make sure we have our units correct, and we want to find R. So we're going to use P equals I squared R. Substituting our values in and rearranging, we're going to get the resistance is equal to the 9,000 watts divided by the 15 squared. Again, putting that into a calculator, we are going to get a value of resistance as 40 ohms. Now in these questions, you always need to be careful that you answer in that we have the correct units for our formula. So standard units for power are watts, and the standard units for current is amps, which gives us ohms as our resistance. Last question, we have the step-down transformer, so we're going from 49,400 volts down to 250 volts. So we've lost some of our 50,000 volts in the transmission, which is to be expected, and we want to go to 250 volts. We need to calculate the current in the secondary coil divided by the current in our primary coil. If we go to our transmission formulas, the current in our secondary coil over the current in our primary coil is equal to the voltage in our primary over the voltage in secondary. Note how that the primaries and secondaries are switched around in current and voltage, because if one goes up, the other has to go down. The voltage in our primary coil is the 49,000 here, so the primary coil is that first one, so we have 49,400, and just erase that, 49,400 divided by the secondary coil, which is this one here, which is a 250 volts. So as a fraction, it's that. If we want it as a decimal, that ends up being 197.6. And that is the ratio of the current in the secondary coil divided by the current in the primary coil. That's all we need to do. So we don't actually have to calculate the current. And that is our question done. So that would be worth probably around sort of 5 to 6 marks in your exam.